This is a smartphone, and yes, we designed, assembled and programmed it here at the lab. The phone is built around ESP32 chip, which comes with 520KB of SRAM and over 30 configurable GPIO pin, lots of peripherals for connectivity and 4MB of flash memory. For default communication on our mobile phone, we use SIM868 which support GSM, GPRS, GPS and Bluetooth communication. The beautiful thing here is that the SIM chip supports 2 SIM slots, which makes it flexible for use. For the visual interface, we use a 240 by 320 TFT display, which supports screen touch functionality and can be programmed onto our microcontroller via SPI. These 3 main components are the building base for our hardware integration in our mobile phone, and with this, we kickstart our design for a mobile phone that can call, message and do pretty much everything a phone can do. We started this project over a year ago, and this was bettered after we built upon so many of our client proposals for solutions that cut across its features like call trigger system, SMS, GPS tracking, radio and many more. So we thought of fusing all these features in one PCB and programmed them to run as a mobile phone. For the first part of the build, we started by integrating all the functional parts of the schematic diagram, which include the sensor circuit, the keypad, the SIM circuit and many more. Next, we drafted the shape of our board while referencing an existing panel. The idea is to help us constrain our mobile phone to the size of available phones in the market, and hence we designed the board layout on our software and started component placement. With calculated dimension, we form our PCB keyboard layout, which is done on the first layer of our 4-layer PCB. The rest of the components were placed at the 4th layer, which will be the phone back, and with this done, we started routing. For this procedure, we have the top layer as our signal line, the second layer for ground, the third layer for 3.3 volt line and critical power lines, and the last layer which support the rest of the signal with adequate ground plane. Completing the routing process, we exported our design for production and have the board looking like this. Days later, our manufactured board arrived and we reviewed them for confirmation of the design, and everything looked as expected. We started assembly, and with the soldering paste, I applied solder on all the soldering part of the PCB. With this done, I started component placement. After I completed this, I carefully placed the board on our preheating station and power it up. Around 180 degrees, the soldering process started and I ensure all components are in position. And after a few minutes of cooling, I removed the board and inspected the soldering. For the first test, I will check the charging system. Powering with the lab-based power supply, the indicator lights turn up, and measuring the voltage, I got up to 4 volts, which is well enough to charge the battery. To run the first code in order to test the board, I wired the PCB to program it via our external UART board. Uploading a simple blink code, the blue LED begins to blink, which shows that the board is responsive. With this result, we now move ahead to the next test, which is to test the sensors that are connected via I2C. The result worked out great, and next in line will now be to interface this reading via the display. Applying a soldering paste on the pad, I carefully soldered the flares to the board. Now, it's time to test it as I upload a simple test code. With this test code, I was able to interface our company logo, and with this, we are now ready to start writing the phone's firmware. To aid the process, I will start by integrating the keyboard for the phone. I placed the control key first and soldered them, and I also did the same for the rest of the keys, coupled with the resistor network which aid us to detect which key was pressed. With that done, I used a transparent tape to cover the keypad. I uploaded our keypad debugger code to our phone, and with this, the phone can identify which key that was pressed. With all this now completed, we uploaded our mobile phone firmware, which supports some of the functionalities we want to test. While this process was going on, we started a model of our phone enclosure on Fusion 360. We did ensure that there is high level of tolerance in between the enclosure and the PCB, and to achieve that, we measured all dimensions and duly noted them. Here is the final phone model which works as per programmed. I can access the menu, message, call and pretty much all the rest of the menu the phone houses. In the meantime, we are working on other sub-menus and other integration which we are testing, as well as the user experience and the user interface. With the current UI UX, let's make a call. I can choose to use the contact list or dial a new number. Using the save contact, let's call my phone.
Hello, yes.
Okay, it's okay, you don't need to talk, just keep the camera before quite close. So,
Yes, I can hear you.
alright, so what goes on here? And the call comes, let's see the face, what we have here. Alright, so the call comes in here and then you can receive and you can as well hear, but I need to use the headphone. Alright, so you can call the call. It's amazing to see that I can call, talk to anyone via this mobile phone. Next, let's enter into the message menu. Since we haven't completed the configuration for the alpha case, we loaded the default message which I can set from here. So here is a demonstration. I have this message option and I open it and then send it to this number 090 and you just input the rest of the numbers. And here we are, the message we received. Apart from this function, we can test the touch, which will need me to toggle through the menu to access it. With this, I can now turn the touch on and off. The hardware menu helped me to run a troubleshoot on the hardware integration, which you can see all the reading ranging from the phone accelerometer, gyroscope, real-time clock and Mastati 105 sensor. I'm considering to use the sensor as a finger lock for a mobile phone. As you can see, it detects my finger when I place it and also it detects it when I remove it likewise. We are currently developing a lightweight operating system for this phone as we're already planning version 2 of this build. So much more has gone into this, ranging from resources, time, troubleshoot and planning, and this is one key project that we know that we can pull off and even more as it takes great input from the team here at MEmbedded TechLab to pull this one off. We are rounding off our first firmware soon, which will cover both game, radio control, internet access and many more. We can't wait to share this with you as we appreciate your input and feedback. Thanks so much for watching and I will see you in the next video. Do have a blissful day.